And so, Nancy, what you got?
I don't have anything. I just arrived and I realized I came with my apron. I'm at school with my apron on.
You what now?
I just went and grabbed breakfast. Can you believe it?
Oh,
Since
you
I
have an
last spoke to
apron
you,
on? Is
I
that what you
actually,
said?
yes, I fried a
Okay.
couple eggs, did toast, and I'm laughing because I came to school with my apron on.
Oh, okay, okay. All right. Well, I came to school with shorts on, so what the hell? It's all good.
Well, that's a good thing that you have shorts on.
Yeah, it's good. It's better than some
Yeah.
newscasters, I guess, news anchors, when their camera actually pans down. Oops, not wearing anything. Anyway, all right. Okay, so we pretty much finished chapter 5. Let me kind of look at the last section in chapter 5 with you. It's mostly about being able to read graphics, ways to display data. So I think we went over a couple last time. I'm pretty sure we looked at, oh, shit and a half. What have I done? There it is. Okay. All right. Monitor, wake up. Monitor? What happened to you? Monitor. All right. So can you guys, we did look at this stuff here, right? I'm pretty sure we did. We looked at this. So they're going to give you all these different ways to represent data. So here's some math test results by country, right? So this is a double bar graph because for every country, they have 2 bars representing boys and girls. Finland is always kind of a big place to compare mathematics to. South Korea obviously doing very good, Japan doing very good, but Finland's doing good, and their gap between their genders is nowhere near as big as some other countries. Of course, United States. All right, that's all we'll say. Blah 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 blah. Here's a different kind of graph that we don't see as much, and this is one of my, especially because I don't something went wrong with the book. So it's kind of hard to read what the hell's going on. But even if there wasn't that typo, even if there wasn't that mistype there, this kind of graph I really don't like as much. But it is sort of like a pie chart put into bar graph. You guys know pie charts, right? It tells you the bigger the pie piece, the more that's there. So it's basically what this is doing. Blue is tuition and fees. So you can see it's the biggest part of most of the bars. And then light blue is room and board. So you can kind of see the percentage of each that those categories take up. Is everybody with me? Has anybody ever seen, you might have seen graphs like this somewhere, but it's not too hard to tell what it's trying to say. It's just, it's not my favorite graph. Then you got this weird thing, which is sort of the same thing, but it's a little bit difficult to read when you first see this kind of thing. But the wider it is per year, the more was in that thing. So the more cardiovascular death rate, higher the cardiovascular death rate was when you got a big thing. But what is happening down here? Who's this? What is this? Red, brown, whatever the hell this color is. Cancer. Cancer's steadily taking up a bigger part of the pie. Are you guys okay with me out there? Nothing major here. It's just, these are going to be problems that are just going to say, can you interpret what this graph is trying to tell, right? And we have to do this in our daily lives to make sense of stuff. They throw this kind of stuff at us all the time. Energy usage, you got to pay attention to, the first thing I look for is the extremes. So Wyoming, for some reason, is Wyoming like that much colder than North Dakota and Montana? So they're using a lot of energy there. California, not so much, but it's per person use. Okay. Anyway, I don't want to get too deep into what any of these mean. This is a very straightforward map to read, a very straightforward way to give you data. Blah, blah, blah. Here, well, this is again a bar graph, but it actually has 3 dimensions to it, which is really nice. The height is the CO2 emissions. This axis is which country, and this axis axis is which year. This is actually, I love this kind of graphs. Ooh. I don't know if you're like, does anybody have a favorite kind of graph, or is that just me? I understand. Let's see, blah, 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 blah. Okay, so not very exciting. And then this is the one I think most of you guys have seen a lot of, maybe. Have you guys seen stuff like this? They just throw everything at you with little pictures and stuff. It's like, whoa, my God, wait a minute. So I don't particularly enjoy this. If they broke this down more, it might be better. Anyway, okay, enough of that. And they also talk about perceptual distortions, like area is not a great way to reference how things change, so you could read through that. We did talk about making your axes wrong. Do you guys see the problem here between these two? What's the,
No.
they're both the same graph. Go ahead, Nancy.
No, I don't see the problem. I don't know what the problem is.
The one on the left, even though it's a timeline thing and it's supposed to carry just to the right, it dips all the way down in the 1950.
But that's not, of course it does, because that's the truth. That's what happened. But what is that? What's the
One
scale?
starts at 0 and goes to 100, so it looks less dramatic.
And actually, this is the correct way to represent things. This is to make it seem more dramatic, right? Now, I'm not saying that there is an issue with back here with how many women were a percentage of college students. There was a problem with allowing women into college, and they couldn't even take certain majors back in the day. So that was obviously an issue, and you can still see that it was an issue. But this is really just trying to make it look worse than it was, which does a disservice. I hate this so much when somebody has a point that I agree with, but they're doing things like this to make it when it's unnecessary. This is already showing the problem, or this is showing how it's improved well enough on its own. This, somebody could say, oh, you're distorting it, and then throw out the whole argument. Are you guys, is this too much for Monday morning? I'm sorry. But that sucks when like, I agree with you, but you're doing it wrong, and they can just throw the whole argument out. What are you doing? I hate that. All right, I'll get over it. Maybe, I don't know, maybe not. Oh, and this is the last thing. They don't get too deep into this. These both show the exact same data. Can anyone see the difference here? Do they both start at 0? Yes. So it's not a distortion. It's not trying to lie. What kind of scale is this? What scale is this? Let's start with this one. What scale is this one? What's every step?
20,000.
20,000. What's the step size? Is there a constant step size here?
It's a multiplication of 10, right?
It's a multiplicative scale. This is called a logarithmic scale. Oh, shit, Jeff. And you see this all the time. A logarithmic scale shows how much growth has happened on top of what's already there. So do you see how this isn't distortion, but it kind of loses the idea. I don't know how to say this. So like you'll see logarithmic scales all the time for COVID case growth. Because of course, if there's more cases, that's going to create even more cases. So this is not very useful graph, because you see how I don't know what's happening down here. Whereas here, I can see much better. Anyway, I don't want to get too deep into this. We'd have to go further into the math to really tell what this means. And if it's a straight line, what does that mean? Anyway. Oh, let me just show you this. Let me go back to my favorite. It's not really the right way to describe this, but my favorite website for keeping an eye on COVID. Let me refresh this. You can buy some pants over here. All right. Let me see, where am I at? I'm in America. Okay, so look here, logarithmic. So this is the linear scale. And then if I hit logarithmic, what you want to see with a logarithmic scale is you want to see this thing flatten out. If it flattens out, that's a good thing. So it's definitely flatter than it was, but it isn't flat. That's why we're not doing so great. There could be other countries that it's a lot flatter, which means they're doing better. But this is obviously a good way to represent it, which is why they do it. But this has meaning also. Okay, that's enough, Jeff. That's enough. That's enough. I don't want to get too deep into the math there because we're not going to start talking about logarithms all of a sudden. All right, let me get back to this. Bam. All right, I think that was all I wanted to show you. Yes, okay, good. Yeah, that's fine. All right, so that homework shouldn't be too evil. All right. I just this morning created a place to turn in chapter 5 homework, so I'm sorry. Nobody said anything, so I just now noticed I hadn't done it yet. Not surprisingly, it is due tomorrow night. That's sort of surprising, to be honest, because the quiz is tomorrow, right? Anyway, so do enough of chapter 5 so you're ready for that quiz tomorrow, as always, right? At this point, anything that's due this week, if you give it to me by the day of the final, it's not really going to be considered late because, I mean, the final's right there, but you need to do enough before quiz so you're ready for the quiz, as always. Okay. All right, Jeff. Let's see. So any questions left over from chapter 5? Has anybody tried some of that out yet? No? Okay. All right, so we're going to get into chapter 6. And I think, if I'm not mistaken, I think I brought some of this stuff up already. Chapter 5 was sort of the definitions, the terminology of statistics, which is always super exciting. Chapter 6 is the nuts and bolts and the sink your teeth into data chapter, right? So this is where we're going to be starting to analyze data in different ways. I think you're not working too good. Come here. So let me ask you this. I think I brought these up before. There's something we call average, the average. And when people say average in everyday life, they really mean this. They really mean the mean. That is the technical name for what we call the average. In mathematics, the word average could actually mean a lot of different things. But when we say it in everyday usage, this is what we actually mean. Now, can somebody tell me how to calculate the average of anything?
Do you everything up and then divide it by the number of things?
Yeah. So it's the same old stuff, right? You add everything up. So if you wanted to make a little add them all up, divided by how many data points, right? Woohoo! So let's do this. Let's say that I have, I'm the CEO of this corporation, right? And there's me and 3 other people that work at this corporation. I'm the CEO. So this one guy makes 40,000 a year. Somebody else makes 42,000 a year. Somebody else makes 45,000 a year. And then I make $500,000 a year. Can somebody help me out? Just take a minute and figure out what the average is of that. It's not going to be too pretty.
Like 156.7.
Sounds about right. What 156?
0.75.
0.75. Okay, so 156,750. Is very cool because this is all thousands. Are you guys with me? Let me stop for a minute. We haven't done anything yet, to be honest. You all know how to do an average. You came in knowing it. You might not have known that's the actual name of it, but you know how to find the average of things, right? Now, is this a good measure of what the center of the data really is? If I was going to go join this, they're going to hire one more person, right? This guy, Sam. Sam comes in and he talks to these guys and he says, how much money can I expect to make here? And they say, well, the average is $156,750 a year. He's going to be like, holy shit. Yeah. So this is the correct average, but is it the best way to communicate to somebody the center of the data? No, not in this case. What other situations would we not use the mean to describe the center? Think about, I don't know, living in La Jolla. If you wanted to live in La Jolla, what would not be a good thing to give an average for?
The most expensive houses.
Houses, right? House prices. So whenever you see news stories about house prices, this might tickle some of your brains. You hear median house price, median income. Has anyone ever heard the word median used in that way? Okay, so one measure of center, one way to figure out the middle of things is the mean. We know the mean is the average. We know how to do that. But sometimes it's not accurately portraying something. Why is this one so much higher than it should be? What data point throws it off, of course?
The 500,000.
Yeah. All right, let me stop for a minute. Is everybody with me out there? You guys out there? Is everybody out there? Yeah, okay, good. All right, thank you. I just want to make sure because I can only see Nick. Oh, there's somebody. Hey, Danielle's like, dude, I'm here. Chill out. All right. So what do we call this kind of thing? What do we call a data point that's really not following the pattern of the other data points? Reggie, what's yellow? I don't know. Sorry?
An outlier?
Say again, sorry.
An outlier?
Outlier, exactly. I love it. Right? All right, I got to tell you my stupid story. It's not a story. Has anyone ever seen that movie, Children of the Corn?
Yes. Pretty good one. Cult classic.
And whenever I say outlier, I always think about the one scene, Outlander. We have your woman, outlier. All right, sorry. So that is called an outlier. It is an outlier because it lies outside of the normal range of the other data points. We all know, we've seen that word before. We've heard that word before in different contexts. Okay, all right. So I'm going to erase all this business and we're going to talk about median. All right. So we got mean, and now we're going to talk about median. And median is exactly what it sounds like. Where's the median in a road?
In the middle.
In the middle. Has anyone ever driven across that bad boy? I have, late at night, make the turn too wide. Oh, shit. So median is the number in the middle of the data. Physically in the middle. So for example, what is the median of this data here?
3.
I love it. Now notice something. All right, let me just leave this alone. So the median is 3. I love it. What about for this data?
1.
5.
5. Wait a minute. Is it just my crappy writing? Let me try this again. There we go. Answer is not 1. Is 1 in the middle of the data? I mean, think about it. So if this makes sense because 3 is right in the middle between 1, 2, and 4, 10. What is wrong with this data? Why can't I look at it and tell what's in the middle?
Not in order.
Out of order. Bam. If you could put it in any order, Danielle's like, I was going to say it. If you could put it in any order you want to, you can make anything the median. And then the median is meaningless. Whoa. Right? So it's got to be in order. So if I put it in order, 1, 2, 7, 11, 58. Now you can see the median is
11.
7, right? Isn't that right in the middle? Isn't 7 right in the middle physically of all the data?
Yeah,
So-
okay, physically, yeah, okay.
Yeah, it's right in the middle. 5 numbers, the one in the middle, no, is that be evil? The one in the middle, kids. No. So it's going to be, in this case, it's the third number in. So let's stop for a second. What was I going to say? Oh, the mean, if I did the mean of this, what would affect the mean the most here of these numbers?
58.
The 58 would kind of stretch it up, would it? Does the median give a shit about outliers? Does the median change? If I change this to 58,000, does the median change?
No.
Nope. Would the mean change?
Yes.
Hell yes. So going back to that earlier example with the incomes. Chip, you have no, all right, screw it. Remember the incomes we had earlier? Let's see if I do. What was it? 40, 42, 45, and 500,000, right? Is that what it was? Now we get something interesting. These were easy because there's an odd number of numbers. Anytime there's an odd number of numbers, there's one that's definitely in the middle. Does that make sense? How many numbers does this have?
4.
Shit. Is there a number that's in the middle?
No.
Is one of these in the middle?
No.
No. How many are in the middle?
4.
No. Are you guys, let me stop for a minute. Does everybody understand the issue right now? Median is a very simple idea if there's an odd number of numbers. Odd number, there will always be one in the middle. What do I do if I have an even number of numbers? Well, I want the number that's right here. So what would I do with the 2 in the middle?
Find the mean.
Find the average, find the mean. I love it. What's right in the middle of 42 and 45? What do you get when you average them out?
43.5.
43.5. So coming back to my earlier example, you wouldn't tell Sam, the guy who's coming here for a job, that he can expect to make 150 something thousand a year. You would tell him the median income is 43,500. That's a much more honest answer, correct? It's not affected by the notorious CEO, right? Okay. So when is the median more accurate than the mean? When there are extreme outliers, right? So I'm gonna erase this whole board. Here we go. Yes, Ian?
Oh, nothing. I was gonna say that I think I've been taught the difference between median and mean, like across a dozen different math classes, but I don't think anyone has ever told me that specific piece of information.
Oh, well, that's not good. Sorry, it's not your problem, but it's whoever taught you that. That's the most important thing to tell. If you're teaching mean and median, you have to tell why one is better than the other sometimes, and that's why. The mean is the one we use in statistics most often because it takes all the data into account, and the median doesn't. But if I'm just trying to describe a data set to somebody, the median is a decent number of times the most honest way to give it, the measure in the middle. All right, I'm not sure what 49. Okay, I got to keep up with the chat. When I look at them, I'm not sure what's on. Okay, so I'm going to erase all this stuff here. Let me ask you a question. Is every data set numerical? No.
No, there have to be some alphabetical.
Well, they could be non-numerical. So I could say, well, let's write down everybody's hair color, right? Could you find an average hair color?
Yes.
How?
No.
Okay. You could arbitrarily assign numbers, but then that's finding the average of arbitrarily assigned numbers. You could say, I was waiting to see if anybody would say, you could take the wavelength of the light that represents each color. And they did that for the universe, and they found out that the average wavelength of the universe is beige. That doesn't sound good. But it sounds like what you'd get if you mix all the color. Couldn't you have a beautiful painting and then you mix all the colors together and just get a pile of shit, right? So I mean, you don't try to average things like that. So if I have something that's non-numerical, hair colors, types of cars, whatever, I can't do the mean or the median. Don't the mean and the median require numerical values? Right? Yes. So this is our third. So we have mean, we have median, and then we finally have one that works, even if it's not numerical. It's called the mode. And the mode is just the thing that occurs the most. So if I ask everybody what kind of car they own, I can't take the median of that. I can't take the median of that. But I can say, oh, most people own a Hyundai or something, right? No. You guys with me out there?
Would it be like qualitative versus quantitative? In that way?
Ooh, neat. The big Q words. Yes, exactly. So these work only with what's known as quantitative data, which we're just going to call numerical data. This works both with quantitative and qualitative, meaning numerical and non-numerical. Kick-ass. I like it. So, I mean, if I talk to people and 48 people own a BMW, Jeff, really? 511 have a Chevy, 509 have a Ford, and 650 have a Pinto. No, Jeff, yeah. Have a Hyundai. Hyundai. Then the modal car is Hyundai. You guys all know. That's the one that occurs the most. All right, let's see how this works with numerical data, because it works with both. I'm going to erase this. So example, what if I had 1, 2, 3, 5? Sure. Is there any mode here?
5.
Did 5 occur more often than the other ones?
No, it did not.
Good. So is there any mode here?
Nope.
Good. All right. So no mode. So what about this thing? Ooh.
2.
2.
Holy shit. Yes. All right. So mode is 2. What about this data? That's a comma.
2.5, or would you just say 2 and 3?
They're 2 and 3. The mode tries to tell where the data is clustering. This data clusters around 2 and 3. This is what we would call bimodal data. Two and 3. The answer to the mode can never be something that doesn't even show up in the data. Does that make sense?
Professor,
Yes.
the mode tells where the data is clustering.
The mode tells where the data is clustering. Yes.
Thank you.
You guys with me out there? So you can have no mode, you can have one mode, you can have 2 modes. I don't know if this book talks about, the most I've ever seen is 3 modes called trimodal. And then once you have more than 3, it's like it's not clustering anywhere. It's just spread out. So what about this data? What's the mode there?
70.
Yeah, totally. There's a winner. So I get people to say this and this because they both repeat, but who wins? 70. You guys see that? Don't just look for the repeats. Look who repeats the most. One more 55, it would have been bimodal. Okay. So mode is the one we use the least, because sometimes it really doesn't mean anything. But I mean, sometimes it is very important. That's why it's there. All right. So that one, I always think about pile of mode. And I want to be the one that has the most ice cream. Nah, whatever gets in your head. All right. So we have, for telling where the center is, we have 3 options. Mean, which kind of wins. It's the one we use most. Median is sometimes the best way to describe data to somebody. Mode is sometimes, I mean, for one thing, it's the only thing that works with non-numerical data. It's got that going for it, but otherwise it's not really used that much. Okay, I like it. Use the mode all the damn time, right? Who ate the most hot dogs? Who sold the most cars? Who, you know, we use the mode all the time, but for descriptive purposes normally. All right. Let's see. Oh, okay.
Professor, can you repeat that just one more time? How you just explained mean, median, and mode, please?
Oh shit.
Just really simple. Right now, you just said median is to describe something.
Yeah, mode.
Mode, and then mode.
Mode is how do I want to say this? Darn it, I just said it and you're right.
Non-numerical.
The mean is the one that wins out. It's the one that statistics uses most often. The median is sometimes the best way to describe a set of data to somebody. If there are outliers, extreme outliers, right? And the mode is the one that is the only one that works with non-numerical data. So it has a kind of a specific reason that it is sometimes the most useful one, is if I don't have numerical data. And like I said, in everyday life, we want to know who got the most Easter eggs, who whatever, right? Who got the most impeachments? No, stop, Jeff, stop.
Got it. Thanks.
Sure. Okay. Winning. Here's hear the sound of victory. Okay, here it goes. I want to give you an example of a really something that really grinds my gears. If anybody gets that reference, good on you. You hear this all the time in politics when they discuss the things like tax refunds and so forth. They say something like the average family got a tax refund of $1,000, right? Have you guys heard something like this before? Alejandro, what's up? You okay?
Yep. I'm just
Okay.
scratching my head. Sorry.
That's
It's
right.
really windy here, and this is gonna, just in case something goes down, Wi-Fi or anything.
Sure.
This is gonna be on there, right? Because the wind's like super strong.
No, I'm just recording this one for myself. No, it's good. I'm sorry.
Thank you. Please share it.
I'll think about it. Of course, it's going to go up. Yeah.
Just cut me some slack. I haven't finished my coffee. All right.
You're good. You're good. All right. I don't know. I like to be evil sometimes. I'm a math teacher. I mean, come on. All right. What was I saying? Oh, geez. Oh yeah. All right. So if they say that, in fact, this has happened very recently. The average family got a tax credit or whatever of $4,000. And then people are like, oh, wow. Even though they know they did not get that, they're still like, oh, wow. Stop it. So all right, so let's say that there's $1,000 average tax refund. Right? Now, let's examine this. What if one person got $100,000 refund, and then 99 people got 0? Please take a minute. Let me see if you guys can do this. What is the average refund for this group of people? How many people are there in this group? 100.
The average,
Now stop, don't say the answer yet. Just take a minute, see if you can figure out the average refund for this group of people. This is a very extreme example. This is not the reality, but this does capture the problem with saying something like this. And I'm not saying that every time something like this is said, they intend to deceive people. But most of the time, they know people don't have a freaking clue what the shit it really means. And they love it. They love it. They can just tell the truth and lie at the same time. Ooh, they really love it when they can do that, right? And I'm not talking about any specific political party. They both do this. One does it more often, but no, they both do it. So who's got the answer? What do you get when you take the average? The total amount of refund was 100,000, right? Divided by how many people?
100,
100 people. What do you get?
1,000.
So if yeah, there, Jeff, you can do it. You can do it, buddy. There it is. If I was the ruler of a little island and I said, oh, everybody, listen, there's $1,000 average tax refund. And they're like, yay, you're amazing, you're awesome. Even if the family got nothing, what's weird is they still are like, oh, we didn't get anything, but you're awesome. You $1,000 for most people. That's fantastic. Oh, you're awesome. No, right? I mean, I'm not saying this is what the reality, I'm not, but I am saying the reality is closer to this than it is anywhere near to everybody actually got $1,000, right? But when people hear this, they think everybody got $1,000. That's what you think, which is nowhere near. All right, stop, Jeff. Stop. I'm sorry.
It's just that the only thing is that they fell into the average.
Say again, sorry.
The point here is that they fell into the average, even though they didn't get the 1,000. They were part of the average.
True, but you do get my point, right? That it's a way to lie without lying.
But if you-
Yeah, and
if
I'm
you
busting
did
up
it-
because I've seen it so many times.
Good.
If you did it in like a mode where you said got something versus got nothing.
Yes,
then
the modal
yeah.
refund was what? What was the modal refund? That's a
none.
weird word, I know. What was the
0.
0? 99 got 0. So the mode is 0 for damn sure. But the average was 1,000. What was the median refund? If I wrote all the numbers out, what would they look like? 0, 0, 0, 0, 0, 0, 0, 100,000. So what would the median? The median would be 0, right? So they should be reporting median tax refund. Median. Now think about what this means. If the median tax refund, let's go away from this really extreme example. Let's say that if they said the median tax refund, let's say they say the median refund was $150. What percentage of people got less than 150? You can do it. You can do it. If the median is 150, what percent got less than 150? You could do it. Where's 150? Here's the list of data. Where's 150? It's right in the middle, right? Right in the middle. So what percentage got less than 150? Shop 50%. So the median always tells you 50% below, 50% above. When we hear average, a lot of people think that that's what average means, which is why they get taken by this kind of thing. This is bullshit. So that's another situation where median would be much more honest. So this is what I mean by they're lying without lying. Right? We just have to know the right thing to ask. And what pisses me off is when somebody doesn't just point that out. Just take a second and say, well, we calculated the median is actually this. Just say that. Just count. Anyway, so I'll stop. Okay. All right. Do you understand? Do you see, even if you hate math or something, do you understand why it's important to know some math? Because otherwise you are so easily manipulated. Easily manipulated. It's insane. You don't have to know a lot of math, and then you can manipulate the hell out of people. It's crazy. All right. Let's see. What time is it? Yeah, let's take a little early break. I need an early break for some reason. So come back. What time is it? Yeah, let's come back at 10 after 10. Let's make it a nice round thing. 10 after 10, come back. Let me know if you need to hang out right now. What's up?
Oh, I was just going to say I'll be here.
Oh, okay. All right. There. So I went ahead and created the office hours link for this week. Today, the 25th, and Wednesday, the 27th, 3:30, 4:30. That link will work for both, right? So if you want to come to those. And we're not quite ready for this, but just to show you, I did make a new Unit 6, and there is a sheet. We still have to talk about the last two things, but that is where you're going to go here in a minute to get this kind of worksheet to work on. But we're first going to talk about these two weird things. All right, enough of that. All right, so let's do it. And by the way, just to let you guys in on some thought process I'm having, I am considering making one more section extra credit just to kind of give us a little bit of an easier last week, because it's already full of 2 quizzes and a final. So I'm pretty much, obviously by saying that, I'm going to do it now, because it would be really evil if I'm like, I decided not to. So I just got to figure out which one I can kind of let go of. Anyway, all right.
Thank you for that.
Of course. And again, not to make it all about me, but that helps me out too. So, but it helps all of us. That's the important thing. All right. So we just discussed mean, median, mode. I do want to talk a little bit about, let's see. Let's go ahead and talk about this a little bit. If I had a distribution, so this is a little bit, let me do it like this, because this is the way you guys are more used to seeing data, possibly. If I had data that looked like this, would you say that that's pretty much symmetric data? What's your gut tell you? Is that pretty much symmetric?
Yeah, that looks symmetric to me.
Yes.
Yes. It also looks like a 7-fingered man giving us the finger, but that's okay. We'll get over that, right? One more finger than the Princess Bride, dude. How many fingers do you have? So what would this be then? Is that symmetric?
Asymmetrical?
Yeah, it's not symmetric, right?
Asymmetrical?
It's asymmetrical, of course. It's not symmetric, but there's a specific name. So this is a type of symmetry. Just to make sure you guys are cool with symmetry. Symmetry could also mean this. It doesn't have to mean. Isn't that symmetric? Do you guys understand? It doesn't have to mean the highest point in the middle. If I just put in a mirror right there, then it's a mirror image of itself. That's all symmetric means.
Yes.
I want to make sure you understand that. Symmetric does not mean it has to look like this. It doesn't have to look like this or a ghost, right? Normal or paranormal. It can look like that, or it can look like wee-haw, wee-haw. That is symmetric. This is not, but this has got a specific name. This is called skewed. And which way, if this was a bunch of taffy, which way did somebody pull it? If it originally looked like this, which way did somebody pull it? If it looked like this, where did somebody grab onto it and pull it? If it was like taffy, you could do it.
The right side.
Yes, doesn't it look like they took this and pulled it and stretched it out? So this is skewed right. Isn't that crazy? So can you guys imagine what skewed left would look like without me drawing it? Yes. Okay. So we have these ideas of symmetry, and then we have an idea of skewness. Yeah, there's a word called skewness. The skewness of something. The more you say it, the weirder it gets. All right, maybe. In symmetric distributions, the mean equals the median. Does that make sense? Wouldn't the median be this? Wouldn't the mean be this? If you think about it, okay, so that's just a little more technical note. So if it's not symmetric, then the mean is bigger or smaller than the median, depending. Okay, maybe. Okay. Where's the mode in these pictures? In fact, I want to make this, understand what these pictures represent. What does the height represent in these pictures? Let's say this is ages of people in a class. What does the height represent?
The highest number of a specific age,
Yes.
or the frequency, highest frequency of a specific
Yeah,
age.
the frequency. How many people are in each of those categories? So this, the highest peak would be the modal. So this would be bimodal here, correct? And of course, this one is more true to life for college classes. A lot of people out of high school, and then me with my older folks, right? I like it. Lifelong learning is good. Okay.
So what does the height represent again?
The number of data points. So if this was 30 years old, then 30 years old is the modal class. It's the one that occurred the most because it had the most people in it. So this scale would be numbers of people, right? 10, 20, 30, 40, 50 people. Does that make cents. So the height represents how many are in that category. So this could be the category 30 years old, and most of the people are in there. Okay, all right. So let's get into the next idea. So we've discussed measures of center, and the measures of center do come into the idea of symmetry and skewness, right? Because mean and median are the same if it's symmetric, but not if they're skewed. So then the next thing we've got to talk about is measures of something called variation. Measures of variation. So if I had one set of data that looked like this versus another set of data that looked like this, which one has more variation?
The one on the right?
Yes, it's more spread out. So variation is kind of a measure of spread. So if I was drawing these curvy ones, this one would have very little variation, whereas this one would have a lot of variation. The numbers get further out more often. So there are multiple measures of center, mean, median, mode, and even more than that. There are other measures of center beyond that, those three. And there are multiple measures of variation. The most basic measure of how spread out the data is called the range. And all the range is the highest data point minus the lowest data point. So what's the range of this data set here?
1 and 10, 1 to 10.
Careful. High minus low. The
Oh,
range.
10,
No.
10 to 1.
High minus low.
Minus
9.
So 9 is the range. It ranges over 9 data points, right? That's kind of like the range of it from 1 to 10. You guys okay out there? What's the range of this set of data?
Is it 7 minus 7?
Yeah, so it's 0, right? That has a range of 0. Okay, maybe. You gotta love range. Range is just how far does your data go from what to what, and you subtract those two things. That tells you the range of the data. So if people were in the room and it was anywhere from 20 years old to 70, doesn't it make sense that they range over 50 years? From 20 to 70, so the range is 50, maybe?
So for homework, like in the book, what can we expect the questions to be worded like? Is it going to be like this, where we're showing like a graph and it's like, what's the range with like, and the graph's like has numbers on it?
Could be. I mean, so if this was 1 and this was 10, what's the range? 9. It's the highest data point minus the lowest data point. So they can give it to you, and we'll take a look at the homework here in a bit just to be sure we know what's coming. But if you can figure out what the highest data point is and the lowest data point is, subtract them, you got the range. So they can give that to you in multiple ways. One way is just to give you a list, right? Does that make sense, everybody? So that's all the range needs is the highest and lowest data point, subtract them. That's all it needs. Okay, I like it. Hey, Mikey. All right, let me give you the one example I like to give to remind everybody how math works. What about if I had data about how the temperatures in Alaska over a certain range of time? What is the range here?
From -11 to 13.
Okay, that's what the data goes from to. Now, what's the range?
24,
I like it because what's the highest data point?
13,
All right, so the highest data point is 13 minus what's the lowest data point?
11, well, negative 11.
Do you guys understand? This is how math works. There's an idea, and then we use the idea. Math doesn't give a shit that some of our numbers are negative. We do, because that kind of throws things off. But what do? We do the idea. What's the highest minus what's the lowest? Now, what happens here? Minus and negative is plus, so you get 24. Yeah. So there's a rate. How far from -11 to 0? How far is this? From
11.
-11 to 0?
It's 11
11. And then how much further do I have to go?
plus 13.
That's why it's 11 plus 13. That's why the math ends up doing that. So if your answer is 2, you have to seriously be concerned about yourself. That does not range over 2, right? That doesn't make physical sense. Are you guys with me? Negatives always find a way. It's sort of like Jeff Goldblum, right? With the little drip of water on the elbow, and nature and negatives find a way to screw your life up. They do. All right. So just be careful. Sorry. I was not trying to do a Jeff Goldblum impersonation there, so I can't do that. It's not like Christopher Walken. I wish I could. All right. So we're going to talk more about variation in a minute. We're going to talk about something a little related to that, but it's a little more specific. It's called measures of position. All right. And there's something called percentile. Has anyone ever heard that word before? You could be in the something percentile. If you have kids.
Yes, when kids are growing since birth, they measure their growth by their percentile.
Yeah, and have any of you guys ever seen that chart that kind of looks like this? And it's got, like for height and weight, there's kind of like this would be the median. And then you have the extremes. And one of my friends, he named his kid Max. He just gave his kid the name Max. And sure enough, Max was freaking right there. I mean, well, you named that kid correctly. They're both tall as hell, so it's kind of known that would happen, but still, it's kind of neat. So percentile, what does it mean then? So if you said your kid was in the 80th percentile for height, let's just get an example. This isn't the math of it. This is just the concept of it. What does it mean if a kid is in the 80th percentile height? What would that mean?
That they're taller than 80% of the sample size?
Of the other kids at that age. I love it, right?
I was close.
You got it. You got the main important thing. A percentile is a percentage. It's a percentage that is below whatever score that is. So if your kid's height is in the 80th percentile for kids at that age, 80% of other kids at that age are shorter than your kid.
Right.
I like it. Yeah, exactly. You guys all with me? So in this case, 80% of other kids at that age are shorter. Yeah. So stuff like standardized tests very often give percentile results. Yeah. Let me ask you this. If you made, I'm going to erase this. Here we go. If you were in the, let's say you're in the 40th percentile on a test, can you tell me what your grade was?
An F probably.
Nope, you can't say. You have
Oh,
no.
because
Yeah, go ahead.
because it doesn't give any frame of reference for like what the scores were, just how you did relative to what they are.
Everybody could have made an A on that test. Are you with me? Probably not
Yeah.
a math teacher, but you know, it is possible that everybody makes an A, which means somebody is going to be in the 40th percentile. Somebody just will be, but their grade could be something like a 93. It just happens that 40% of people scored below a 93 and 60% scored higher. You guys understand the difference? So it doesn't mean you made a 40 on the test. It just means relative to everybody else, that's where you fell. So can anyone identify something we discussed earlier that is actually an example of a percentile? One of our M words. No, come on.
Like
Is it the
median?
mean?
Median. The median always has what percent below it and above it?
50%.
50.
50%. Kick ass. I love it. I enjoy it. Now, let's get specific. Here comes the math. All right. So the idea of percentile is remarkably straightforward. Is a lower percentile always worse?
No.
No. If you're in the 10th percentile for golf scores, because everybody understand how golf works, is it better to have a lower score for golf? I don't golf. I don't watch it, but I understand how it works. Is it better to have a lower percentile for golf?
Yes.
Yes. Is it better to have a lower percentile for the time it takes you to complete a race?
Yes.
Yes. Is it better to have a lower percentile for the speed, your average speed in a race?
No.
No. You want to have a higher speed. Does everybody? So I really want you to, the idea of percentile does not change. How we interpret it, is it good or bad? Of course will change. But a percentile always means this percent scored or made or whatever below this score. So if the score 28 is in the 11th percentile, 11% of the data was below a 28. Is that good? Is that bad? I don't know what 28 means. I can't tell. You guys, people get that mixed up. Percentile means one thing. Then we as humans interpret that as good or bad. Okay. So let's do a very specific example. I'm going to create 10 numbers here. Here we go. Oh, this is exciting. Everybody just hang on. I'm not counting as I go. I'm going to stop here in a minute. What am I at? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now, what have I done that's very nice that needs to happen for every data set if you want to find a percentile?
You put them in numerical order.
Exactly. Percentiles don't mean shit. Just like the median. The median is a specific percentile. In fact, median is the 50th percentile, right? And they have to be in order for it to make any sense. So same thing with any percentile. Okay. So can somebody give me their guess for the 80th percentile? Now's the time to get it wrong when the points don't matter, right? So just give me your guess and don't say 14. I mean, I got to have some reasoning behind it. So what number is the 80th percentile? And make sure you guys can read all these things. Anybody?
41 or 49?
All right, stop. You get one guess. So I'm going to take your first guess. So there's one guess. 41 is a guess.
39.
39 is a guess. I like it. So Ian, why do you say 41?
Because it's one of the higher numbers, but not the highest number. I'm just kind of estimating.
A feel it out kind of answer. John, was it John that said 39?
Yeah. The exact same thing. I just eyeballed it.
All right, so let's get more specific. How many numbers are up here?
10.
10. So how many numbers should be below the 80th percentile? 80%, right? What's 80% of 10? You can do it. Come on.
8.
8. So you can look at that a
Eight.
couple different ways. 1, 2, 3, 4, 5, 6, 7, 8. So it would seem that this might be the 80th percentile because how many data points does it have below it? 8, which is 80%. Stay with me. Is everybody with me? Everybody get that idea? We're just applying the definition of percentile. Whatever the answer is for the 80th percentile must have 80% of the data below it. How much of the data must it have above it?
20%.
20%. So 1, 2, that should be the, oh shit. So it's got to do both things. I really want you guys to stay with me. This isn't that weird. And then I want to show you how the median works the exact same way. So therefore, what should I do? Think about median. What do we do? What's in the middle of 4 data points? Not the second number, is it? Or for you guys, I guess it'd be, I don't know, right? 1, 2, 3, 4. So half of 4 is 2. Is that where the median is? No, it's in between the second and third. Are you guys with me? Because of exactly what I'm saying right now. Isn't the midpoint of 4 data points have to have 2 below it and 2 above it? That's why we take the average of these 2. So what am I going to do with these 2 numbers?
Add them together.
Average them. Yeah. So the 80th percentile of 10 numbers, if I do 80% of 10, 0.8 times 10, I get 8. Oh, this is not as hard. This is not, just stay with, there's only 2 things you have to know here. If I do this and it comes out to a whole number, I average that number with the next one. So isn't that the 8th number? So I'm going to average it with that one. Isn't that what we do here? What's 50% of 4? What's 50% of 4?
2.
2. So don't we average the second with the third to get the median? Don't we? Isn't that what we do? So let's try again. So let's recall. If I have 40, 42, 45, 500. How do I get the median? I average the 2 in the middle, correct? Yes?
Yeah.
the median is the 50th percentile. So if I take 50% of 4, I get 2. I get a whole number. If I get a whole number, that means average it with the next one. So I got 8. I'm going to average that with the next one. What's the average of 41 and 49?
45.
45. That would be the 80th percentile. Does 45 have 80% below it? Check. Does 45 have 20% above it? Check. So what do you do if your answer to this doesn't come out to be a whole number? So that's what we're going to look at next. But before we go to there, I really want you guys, in fact, the way that the people that spoke up, the way that you thought about it, you went up here and just picked a number up here, didn't you? Why does that make sense? Because 80% of the way into the list should be up here. Doesn't it make sense that if I want to find a number that has 80% of the other numbers below it, shouldn't I go 80% of the way into the list? Does that make sense? I'm not going to say the answer down here somewhere. That makes no sense. It should be about 80% of the way in. Isn't that exactly what this is doing? 80% of the way in. Why is there a 10 here? Let me make this really, really clear. It's not always 10. Why is it 10 there?
Because there are 10 numbers.
There's 10 numbers. If you have 12 numbers, don't put a 10 there. Right? Understand, as from a student perspective, you're sometimes not sure what to key in on. That is a 10 because I have 10 numbers. If I had 38 numbers, that would be a 38. I want to go 80% of the way in. So what if I wanted to find not the 80th percentile? I'm going to erase this. What if I wanted to find the 75th percentile? The first step would be 75% of the number of data points. And what is 75% of 10?
7.5.
7.5. Is that a whole number?
No.
No. So if I get a whole number, I average that with the next one. If I get anything else, I round up, take that number. So the 8th number is the answer. So the first step is always, where is the answer? And the second step is, all right, what's the answer? So that is the 8th number, right? So the 75th percentile would be 41. Now, before anybody starts crying foul about how many numbers are below 41, if I only have 10 numbers, there will be a lot of repeats. The 74th percentile is also 41. The 73rd percentile is also 41. The 77th percentile is also 41 because I only have 10 freaking numbers, right? You guys kind of with me? So the larger my data set gets, the more data points can be their own percentile. Maybe, I don't know, that might be a little too far. That's a little bit of a technical point. Let's do another example. Let me make some new data, and then I'm going to unleash you on, oh, that's right. And then I have to show you box plots. Oh, shit. All right, so let's make some new data here. What you got, Jeff? 2, 8, 11, 2. What is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Is that good? I don't know. I don't know. Somebody saw one once. All right, let me see. Do I like that? Not really. I'm going to add 2 more data points on, okay? Yeah, I like 2 more data points is perfect. 73 and 81. Okay, so we should have 14 data points total. Okay, so let's do several things. What is the 25th percentile? And let me see if you guys, let me catch up to the book here. I don't think the book actually uses this word now. I can't remember, but they focus more on there's another name for the 25th percentile. If I'm 25% of the way through a football game, I'm at the, say again, sorry?
A quarter.
Quarter. So this would be also be known as the first quartile. And the quick way we talk about percentiles and quartiles is this is P25, which is also known as Q1. So everybody, math people, we don't like to write a lot. So big P, little 25 is 25th percentile. Same thing as first quartile, quartile number 1. What are the steps to figure this out for this data? What's the first step?
Multiply 25 by the total number of data points.
Not 25, what would it be?
0.25.
Yeah.
Yeah.
And what do you get there?
3.5.
3.5, okay. So what's the answer gonna be? I got 3.5. What does that mean to do?
Round up, so it's 4.
Round up to 4. So even if I got 3.07, you would round up to 4. So there's only 2 things that could happen. If I get a whole number here, I average that with the next one. Anything else, I round up and I take that number. So I kind of want a decimal. That's less work. It's like a decimal, kick ass, round it up to 4. And what is the 4th number?
13.
13, yeah. All right, now you guys, please figure out the 50th percentile.
You said any decimal rounds up automatically? So like even 3 would go, like 3.3 would be 4?
Yes, 3.3 would be 4, 3.07 would be 4. I like it. 3.9 would be 4, yeah. Everything goes from up. It's like Donald Trump. So 50th percentile would be 50% of 14, which of course is what? What's half of 14?
7.
7. What does that mean? How do I
7
find the
numbers
answer? Sorry?
7 numbers in.
No. I got a whole number. So what do I have to do? 1, 2, 3, 4, 5, 6, 7. So what do I do?
Average that with the next one.
Average. Yes. So if I get a whole number, I average it with the next one. Anything else, round it up and take that number. Go ahead, Nancy.
So what is the number there next to the equal? You have a 14 and then equal and number 2 right there.
0.5. Is that better?
Thank you. Thank you. Okay.
50%, right? 1, 2, yeah. So here, this means to average the 7th and 8th numbers. So what will we get for Q2? This is Q2. Is that cool? Q2, second quarter. What would I get for Q2 if I average the 7th and 8th?
44.5.
44.5. All right, so let me write here what we got so far. So Q1, because I'm gonna have to erase this because I didn't get the bigger board. Q1 was 13. Q2 we just got was 44.5. What am I going to ask next? So everybody got this? I'm going to erase it.
Fortunately, it's going to be on YouTube later.
Okay, sorry. So of
No,
course,
that wasn't. I wasn't saying that. You're fine.
oh, okay. I'm like, he said that so calmly as I erased it. I was like, all right. So Q3, I would do 75% of 14. I'm going to show you a shortcut in a minute. Is everybody with that? Q3, 75th percentile, right? 3/4 is 75 cents, 75% of the way in. What is 75% of 14?
10.5.
10.5, which means I do what?
Round up, so it's 11.
So the 11th number is the answer. Some people make the mistake, they stop here and they say the answer is 11. That doesn't make any sense, does it? The first step is where's the answer. The second step is go get the answer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 69. So Q3 is 69. What was when we did Q1, didn't we get 3.5? We rounded up to 4, right? If you look at your work, you guys with me? Oh, really? So this is a little shortcut. You don't need the shortcut because we did it without the shortcut. But if I go 1, 2, 3, 4 from the top for Q1, I go 1, 2, 3, 4 from the bottom for Q3. Isn't that nice? Kind of makes sense. It should be symmetric, right? Boogie, woogie, woogie. All right. So now I'm going to do some exceptionally weird shit. Not this. This is, ooh, I'm writing something. What's the lowest data point?
2.
2. What's the highest data point?
81.
81. This right here. How many numbers are this? 5. This is called the 5-number summary. It's a beautiful summary of the data. So we can make a visualization. Holy shit and a half. It's not me, officer. It's my special drink. We can make a visualization of this to represent the data. And this will be something that I'm almost certain most of you guys have seen. You just never knew how the hell to make it. So watch what I'm going to do. I'm going to make a scale that includes all of these numbers. So I'm going to go from 0, and maybe I'll go by 10. 10, 20, 30, 40, 50, 60, 70, 80, 90. All right, you guys all with me? Do you guys notice? Is my scale consistent? What does that mean? Is it always the same step size? Yes. So the biggest mistake I see is people just write these numbers down here, and then their picture always looks this. Of course, it's going to always look the same. Your scale sucks, right? So the scale should be consistent, and it's got to go further up and down than your lowest and highest most of the time, right? You got to, all of these have to fit in here. So now watch what I'm going to do. All right. So everybody, I feel like I'm going fast and slow, but just tell me. Okay. So this is how I take a 5-number summary and I convert it into a standard visual display. I put a line. So I see 2 is about right here. I'm going to put a line there. You guys, I just put a line there where 2 is. Where's 13? About right here. Where is 44.5? About right here. Where is 69? About right there. Where is 81? About right there. All right. Ooh, so instead of little dots, we put little lines. I box off the middle three like this. Do you guys see? I just put a box around those like that. And now you're going to see what the official name of this is. Not really called a box plot. It's called a box and whisker plot. There are the whiskers. So there's Q1, sorry, there's low, Q1, Q2, Q3, high. That really is not difficult. It is so awesome. And you're all like, whatever, dude. So what is the purpose of this, Jeff? Well, if this was scores on a test, I would be sad as a teacher, first off, right? Unless I'm a grad school teacher, and this is awesome. My first test in grad school, I got a 21 out of 48 or something. And I thought, what am I doing here? And the teacher said later, oh, good job on that, Jeff. I'm like, holy shit, the average was like a 20 or something. So anyway, sorry. So if this was maybe a test and I had a different class, same scale, but theirs look like this, which class did better? The top one or the
Class
bottom?
2, bottom.
Yeah, this one did better, didn't they? They had more higher up. Which one had more variation?
The top one.
The top one, especially because the middle box is so spread out. Now, here goes the magic. For both of these, can anyone tell me what percentage is always in the box? What's in the box? The little head. Oh, no. Is that too old of a reference? Do you guys not get that? What's in the box? What's in the box? Sorry.
50%.
Yes. How the shit did she do that? 50% in the box, always. Right? In the box in the movie, it was about 10% of the body, but no, always for a box and whisker plot, a box plot. That will be 50. Why? Because this, isn't that Q3? Isn't there 75% below that? Isn't that Q1? Isn't there 25% below that? So what's always in the middle? 50%. The box always has the middle 50%. So if you look at, do you guys know there are catalogs of colleges that kind of give descriptions and statistics about all different colleges? So they'll tell you the middle 50% of SAT scores and the middle 50% of GPAs of people that were admitted. Are you guys with me? They love that because that's the heartland that cuts off the outliers, right? The extreme over and underachievers that just focuses on the middle kind of regular student, the average student in a way. Not really, but still, it's still something they like to do. Okay, whew. So let's do this. I've talked way too much today, so let me shut up in a minute after I explain to you what you're doing. So go to Canvas, get that worksheet. Let me show you again where that is. Pop. All right, there it is. But let me back up a second to make this look like a student. So if you go to modules and you go down to unit 6, there it is. So I want you to work on this for a bit. So this goes over the mean, median, and mode stuff. Quartile, the 5-number summary, and then the box plot. So basically it's just a review of everything we've done so far today. So work on that for a bit. I'll throw you into rooms. You double check with everybody. We'll do it together. We'll do a little bit more, then we'll call it a day. All right. Let me stop recording. Do this. Look at you remembering shit. That's pretty good. Let me spotlight me. Yay. And then let's do this. Hello, computer. Oh, where is it? There you are. Okay. Bam. Oh, shit. Now I got to do this too. What were you doing, Jeff? During the thing, you could have done all this. Now be quiet. Bluetooth.
Bluetooth connected.
All right. Oh shit. There we go. Why does he not seem normal? Okay, I don't know. We'll find out. All right, guys. So somebody help me out. Can somebody tell me the work they did for the mean? Or just tell me the answer.
Yes, I can tell you because that's something that I did. I added all the numbers,
All right.
1,075, and divided them by the number of numbers, which are 15, and I got 71.6.
All right. Does everybody else agree? I didn't do it. I'm being lazy. I'm just crowdsourcing this. All right, I like it. So you all could have got together and said, let's tell them all the wrong answers. Yeah, so the average was a 71.6. Not great, but not horrible. Well, it's kind of on the horrible side. Does that make sense to me? Yeah, I guess so, because the 47 and the 52 are kind of large outliers. So that is very possible. Okay, find the first quartile. Oh, I'm sorry. Now we need the median. And this is like somebody with a lot of fingers. There's a middle finger here, right? Whenever there's an odd number of numbers, there will be a number in the middle. So the quickest way to do it is the percentile way, right? Half of 15 is 7.5. So you round up to 8. What's the 8th number? Is everybody with me on that? Did somebody do it a different way? Did you guys just kind of
82.
count in? Yeah.
82.
Yeah, 82. So you could count, like 99, 47, 90, and 52. You could kind of count your way in to 82, but wouldn't that suck if you had 89 numbers to look at? So it looks like 82 is the median. And is there a mode?
90.
90 occurs twice and no other number occurs more than once. I like it. Kicking the acid. So notice this. What would you say to a teacher who said, oh my God, the average was below 72? My God, this sucks. What would you point them to argue against that? Anybody? What does this mean? Anybody? So why is it wrong for the teacher to focus on this number and say, man, you guys sucked?
Because that includes the outliers and not the concentrated portions of the middle.
We have major low outliers. In fact, how many people did not pass this? If you're counting C as a pass, 4, right? Which is a little more than a quarter of the class, but still, it's not as bad as this makes it seem. This is a better number to look at. It means half the class made above an 82. All right. And then something else you could point out. So what about this one, the first quartile?
Can I interrupt real quick?
Sure.
When you're adding all those numbers together, are you supposed to be adding for the mean? Are you supposed to be adding 90 twice or just 90 once?
Definitely 90 twice. Did that not happen?
Because that would be 1165.
Ah, okay. Did anyone else? So this is why I should do this. I'm crowdsourcing because normally that works, but let's see. Let me catch up here. Yeah, this is not quite right. I agree. Did anyone else not get it in 75? So be careful. It wouldn't be fair to not add both 90s, right? Does that make sense? If I want to find the average, I've got to include everybody. Because otherwise, what would the average, if somebody got a 10 and then 80 people got a 90, would the average be the average of those two? Would the average be a 50? No, that doesn't make sense, right? So yes, thank you. for speaking up.
I wonder if anybody else missed the second 90 when adding.
Well, maybe because nobody
It's
spoke up.
easy to do that.
Even when I said
Wow.
I didn't actually do it myself, which means,
Wow.
so that's better. That did seem low to me, but I was just going with it because 77.7 is the actual average, which is a good average. That makes a little more sense. All right. Does everybody understand
Only
that?
added it once, but not on purpose.
Okay. Yeah. Okay. Thank you. So yeah, your eyeballs just said, I already saw 90. All right. So be really careful. You got to make sure you get all the data points, especially when you divide by 15. That means there were 15 data points included, right? All right. Does everybody understand what happened there? I should have probably done this, but I went and did other things in the meantime. Okay. So what's the first quartile? What are the steps to figure out the first quartile? Why am I doing A and B? What's the first step?
The first step is to figure out the median of the data set.
Oh, I see. You could do that. But again, what I try to do, oh yeah, good point. Are the numbers in order? I'm pretty sure I put them in order, right? Yes. So make sure they're in order. That's beautiful. That is correct. That is the actual first step. And the same thing for the median, of course, right? They have to be in order. Now, Ian, the thing is, if you had a list of 8,492 data points, you don't want to do the method you're talking about, right? So you could cut this in half and cut it in half again and get the quartiles that way. There's nothing wrong with that. I do try to give a way that would work no matter how large the data set is. But to be honest, if you do cut it in half and then cut this half in half again, that would work. That's a beautiful visual way to find the quartiles. But what do I do if I do it more computationally? It would be 25% of what?
15.
15. I want to go 25% of the way into the list. And what is 25% of 15?
3.75 rounded to 4.
I like it. So then the Q1 is going to be 1, 2, 3, 68. Which, if you'll notice, if you do chop this in half, 68 is in the middle of these. So Ian's way does work. It's just, it only works really well when you have a small set of data that you can look at like that more easily. So we get 68. So Ian, please understand, you could do it that way. Just, I try to show the most general way. It's pretty cool with Q1 so far. Now I could already get Q3, the shortcut. I don't know if you guys remember. So if I count 4 in from the top, from the bottom to get Q1, I can count 1, 2, 3, 4 in from the top to get Q3. Now you could do 75% of 15, right? What is 75% of 15? Is that 11 point something?
11.25.
Then you round it up and you get the 12. But that's 89, isn't it? That's the same answer. How do I get Q2? I would take 50% of 15, which we've already done, right? We've already done Q2 because we already know the median. So Q2 is 82. Whew! So what's the 5-number summary? I need 5 numbers. Hello?
47, 68, 82, 89, 99.
Yeah, 47. And then, of course, Q1, Q2, Q3, and then the high was 99. Yeah, I like it. All right, let me stop for a minute. Is everybody good with that so far? Except for my horrible writing. You're like, I think he's trying to teach us Mayan numerals right now. No, I mean, I think I told you a little bit. All right, I'm sorry. Mayan numerals are like pancakes and blueberries. I love that, but oh, well, too bad for us. We're not going to talk about it. Blah, 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 blah. Where am I? Oh, yeah. So now we can make the box plot. Can somebody tell me what kind of scale they used? Did anybody get that far? Where'd you start?
I started at 40 and then went all the way up to 100.
Sure. And what scale did you use? You went by how much each step?
I went by 10 each step.
10. I like it. 50, 60, 70, 80, 90, 100. Kick ass. You could use different scales as long as it's consistent, right? And then we can find all of those numbers. So 47 is roughly there. 68 is roughly there. 82 is roughly there. 89 is roughly there. 99 is roughly there. So then you box off the middle 3. And then you make your whiskers. So this is the visual that shows the incorrect thinking of the teacher, even though we changed the average. Sure, there are some lower ones, but 75% of the class made almost a 70 and up, right? Do you see that? So this visual is pretty quick to create, and it's very informative, which are the two best things about any visual. Quick plus informative equals kick-ass. All right. Okay. So let's see. There's, yeah, let's do this. We're going to get a little bit into this next idea. Baby steps here. Is everybody cool with that? Handout. I didn't mean to stop sharing too soon. Everybody's cool with that?
Yes,
All right.
Professor, can you post that, please? Believe it or not, I want the scribbles. Your notes.
Yeah, I got you. My scribbles.
Please, thank you. Thank you.
Scribbles are
I want
art.
one after Thursday.
Oh shit. Let's see. Maybe shoot me an email if you think about it to remind me to do this. Okay. Okay. Now, last idea for today. Get over there. So this idea is actually one of the most central ideas to all of statistics. So, no pressure or anything. All right. All right, here we go. Here's something. Do you guys, you probably know about a website called Rate Your Professors, right? Or Rate My Professors, whatever the hell. Have you guys heard of that website?
Yeah.
Okay. And you can actually go there and see reviews that students have done of teachers, right? I haven't looked at mine in a while, but I used to tell my students, if I don't get some bad reviews, I'm not doing a good job. And I don't know how you take that, but I will sometimes have bad students. And if they don't give me a bad review, I am not doing a good job. But anyway, there's another website that you guys might be more interested in that you actually have to pay for. To be honest, I haven't even looked at it in a long time. I don't even know this is still there. There's a website that you can actually go, pay a little money, and they will show you grade distributions for teachers and the different classes they teach. I'm very happy that you have to pay money for it because, I understand that some students are like, this class is going to suck. Let me take the one that gives like nothing but A's, right? Anyway. So let me ask you this. if I knew two teachers, there were two teachers and they were the same in every way. They even give the same average grade. They both give an average grade of a C, right? They both give an average grade of 74.29. I don't care, whatever. Is that enough information to determine which one's better to take? What if I also knew how spread out the data was? So I not only would I know the center of the data, what did I say? 74.27, sure. What if I also knew like this one's distribution looks like this, whereas this one's look like this? So when would I take this one is if I didn't want to fail. See how very few people fail? Do you understand what I'm saying? Most people make in there. So if I'm like, I'm going to suck at this class, I'm going to take this person because I'll make a C, but dear God, I got a better chance to pass here. If I suck in this class, I have a very high chance of making a D or an F, and then I fail. Are you guys at all with me at all? A little bit? No? Does that make sense? So this is what I was talking about earlier about the variation in the data, how spread out the data is. So when would I take this class? I would take this class if I know I'm going to kick that class's ass, because I want the teacher that does give A's. This guy gives like no A's, right? And I've taken the class. I got the highest grade in one of my classes and I got a B. I was like, what's your problem? But it's okay. They were waiting for some deity to come take their class, and then they would have still made an A minus. I'm not bitter still about that at all. Okay. So there is a website that exists out there. It gives you distributions of grades. I'm not going to tell you what it is. I'm not even sure if it still exists. So let's get very detailed about this idea. So this is a concept. Is there a number I can calculate? So if I'm given a set of data, it would be so kick-ass if I could calculate a number that tells me how spread out the data is. So then you can tell me the average and this spread number. And that's the only two numbers I need. I kind of have the visual of the data then. Does that make any sense? So somebody's telling me the average was 74 and the spread is 10 versus the average is 74 and the spread is 3. I mean, that's all they have to tell me. And they don't have to tell me all the data points. There might be thousands of data points. So the measure of center and this measure of spread are the best two-number summary of a set of data. Okay, so it's even a little better than the quartiles, to be honest. Especially if it's this, normally distributed. So, what I want is a measure of how spread out data is. So let me give you a couple of data sets. You can do it, Jeff. Let's do this. Ooh, versus, all right. Which one of these two would you say is more spread out?
The first one.
Yes. The first one is more spread out. I love it. Why did you say that?
Because it has a wider variety of numbers.
A wider variety of numbers, but more specifically, let me just plant the seed in your brain. Well, can you guys, real quick, what's the average of these? What's the average of the first one? What's the mean?
3. What's the mean of this one?
Also 3.
Same thing.
Also 3.
Also 3. All right. So the mean doesn't do enough to distinguish. What's the range of this one?
4.
4. What's the range of this one?
4.
All right. So range doesn't do shit for me. As far as the mean and the range are concerned, these are the same. Does everybody understand what I'm saying? As far as those numbers are concerned, these are the same data sets, but we can see they're not. And the difference is, like Ian said, one's more spread out. Which one gets away from its mean more often? That is fundamentally how we define spread in statistics. Which one gets away from its mean more often is obviously, like Ian said, the first one. So I think of mean as home. So which one has more things leave home? This one has more things to leave home, right? This one is the one that the parents are like, when are you going to get out of this? Like, go get a job, go find a place. Dear God, right? Sorry. Some of you guys might be living on one side or the other of that. I don't know. Okay, now. So what we're going to do, because we're crazy, keep track of these. I'm going to erase this so I can have room, because again, I have no idea how to manage my whiteboard space anymore. We are going to analyze these two. Spread formula. Let's just call it that. So let's look at this one first. Let's look at the one that's less interesting first. So these are my data points. The book just, I don't know, the book doesn't like using letters, but this is obviously what I would call X, because these are the values that this data could take on. So those are the variables. Those are the possible values for the variable. I don't know, does that make sense? No? Now, the idea of spread. Let me even make this more specific. See how slowly I'm talking? And I normally talk really fast. So this is a note. Spread is the average distance from the mean to all of the data points. Spread is the average distance from the mean to all of the data points. All right, here we go. We're gonna go on a little side trip, kids. So everybody got that definition? If I wanted to figure out the average height of people in this class, what would I have to do first?
Measure everybody.
Measure everybody, right? Kind of hard to do nowadays. So I'd probably have to just take your word for it to ask you how tall you are. If I wanted to find out the average length of a Cocker Spaniel's tail, is that a dog that has a tail? I hope so. I don't know my breeds. What would I have to do first? Get a list of tail lengths. Are you guys with me? Do you understand the point I'm trying to make? So if I want to find the average distance from the mean to the data points, I have to first make a list of distances from the mean to the data points. So how do I find the average blank? I make a list of blanks, and then I can add them up and divide by how many there are. Okay, so if the spread is the average distance from the mean to the data points, I first have to figure out the distance. So that would be the data points minus the mean. That's how far away they are. Is that cool? So for example, and we know the mean, remember what was the mean? Oh, I'm sorry. I'm using a symbol that I haven't discussed.
And the book doesn't use it either. Let me just put mean here, sorry. So this symbol I put there, X with the little bar on it, is the actual symbol for the average X or the mean X. I'm sorry, I don't think the book uses that symbol, so I'm just gonna put the word mean. So what is 1 minus the mean? That's -2, right? 3 minus the mean, those are all zeros. Is that cool? That gets 0 away from itself. And what's 5 minus 3? That's 2. Stay with me now. If I were to add these up, what problem do I run into immediately? What do you get when you add these up?
0.
They will always, no matter what, equal 0. Always. Which sucks. You're like, thanks, Jeff. Good job, buddy. This doesn't do shit about differentiating then. If it's always 0, yeah, jackass. So one thing I could, does everybody understand the problem? If I take the data points minus the mean, there will be equal amounts negative as there are positive, because that's what the mean basically does. So this will always add to be 0, which sucks, right? One thing I could do is take an absolute value. I just got to cut this discussion short and say there are all kinds of problems with that. We do that with certain things, but most of the time that is not useful. There's a better, mathematically better way to do this. If I can't take the absolute value, how else can I make these become positive? I can square this. Which means what am I going to have to do at the end? If in the middle I'm squaring everything, at the end I have to do what? What undoes squaring?
Factoring?
No. I appreciate that, though. I like that. If I square 7, what do I get? 49. What do I do to 49 to make it become 7 again? Take the
Square root.
Square root.
square root. So at the end of this, I'm squaring to kill the negatives, which means at the end, I need to take a square root. So if these were like number of dogs people own, this is square dogs. Do you understand? Does that make physical sense? Do you want to go to their house and meet their square dog? What happened to your dog? Was it in the car when they were crushing the car and the dog survived? And it's a little like Picasso dog. Sorry. No, that's just for me. All the jokes are just for me. So if I square all of these, I still want to find, so what I'm going to do, I've made a little bit of a concession. I'm going to find the average square distance, and then I'm going to take a square root. So if I want to find the average anything, I need a list of those things. Do I have a list of the square distances? Yes. How do I find the average? I add them up and divide by how many there are. So then what I get, I can't remember what symbol they use in the book, if they even do. Should I just use the symbol? Sure. I don't know if they use the symbol, but it's a little sigma. It's a little Greek letter. How many data points are there? There's 5. So I know there's so many little technical things. I want to find the average distance. So I need a list of distances so I can add them up and divide by how many there are, because that's how I find the average. Oh shit, there's some negatives. Okay, so let's find the average square distance. So I need a list of those so I can add them up and divide by how many there are. And then I take a square root at the end because I squared in the middle. I want to unsquare my poor little dogs. So not running around freaking people out. You could stack your dogs easier if they were little squares, but that's not a good idea. So what do you get when you take a square root of this?
2.56. Oh, excuse me. No, I didn't square root it. I squared it.
Oh,
Sorry.
you squared it. Okay, okay.
$1.264.
Sounds about right. Now, let me see. There's so many levels to this. What time is it? Oh, wow. I didn't mean to make it this long, to be honest. Let's do this. Let me make this 1 point, and then tomorrow we'll pick up with this. I have a handout for this stuff too. I'm going to throw that up on Canvas for tomorrow. Tomorrow I'll know better what's going to happen with the homework. I'll try to update the homework. We'll see if I can do that. I want to make this 1 point. The work we've done here is assuming this is a population. I agree with what the book does. The book actually does not discuss this at all. So why did I discuss this? Because it makes immediate sense. How do you find the average? You add up the whatevers and divide by how many there are. If this was a sample, which is what the book focuses on, which is what we normally use anyway, so it makes sense, I'm not going to divide 8 by 5. I'm going to divide 8 by 1 less. It's an adjustment for it being a sample. And my God, maybe I'll do this tomorrow. Maybe I'll try to explain to you why we subtract 1, but it does take a little while to kind of lay out an example of why this makes sense. Yeah, let's do that. So tomorrow we'll discuss. So I would do all the same stuff. We actually call this S now. We use a Greek letter for population and our letter for sample. So S would be the square root of 2, would be 1.414. So tomorrow what we're going to do is we're going to do everything we just did for the other data set, the 1, 2, 3, 4, 5. Can somebody tell me, we just did the one for 1, 3, 3, 3, 5, and we got this sample standard deviation. What should be true if we do this one? How should the number compare? What did we say earlier? Which one was more spread out?
The bottom one.
This one. So its number will be bigger than this. So this is that number I told you. That's the number we calculate to tell me how spread out something is. So if that's 1.4 and this one comes out to be 1.8, that tells me this is more spread out. So tomorrow, that's the first thing we'll do. I'll explain why that's 1 less for a sample, and then we'll do this one. So it'll be a nice review. And then I'll point out the handout up on Canvas. Okay.
So for the sample one, the rule is it's always -1, right? It's not going to come out the cut and be like -3 from the total.
No, it's always -1, and there's
okay
very specific mathematical reasons why. When I explain it tomorrow, it won't be as technical of an explanation because we can't do that, but I hope it'll make sense as to why we adjust it for a sample versus a population. Okay. So if anybody needs to hang out, feel free. The quiz should be open now. So you should be able to start the quiz immediately, or you can start it later. I've got my office hours. I did put those up on Canvas, the 3:30 office hours today. Okay. How's everybody? Anybody need to hang out for a bit?
Thank you.
Thanks. Bye.
Otherwise, I'll see you guys if you want to at 3:30.
Yes, I might come back at 3:30. I need to take the quiz and stuff.
Oh yeah. Well, okay.
Thank you.
Sure. Yeah, I'll see you at 3:30.
Okay,
Bye.
I'll be here. Bye, everybody.